Aroma, the sense of smell. The ability to know what is cooking in the next room by simply taking a deep breath of a mixture of air and the volatile compounds wafting about. The word aroma, according to Webster Dictionary, dates back to the 13th century Greek and Latin word meaning spice. The ability to sense an aroma comes from the use of our first cranial nerve, the olfactory nerve. This nerve is located directly underneath the frontal cortex of our brains. The olfactory nerve senses aroma via chemoreceptors. The pathway an aroma takes from the air around you to your conscious mind is through chemical compounds drifting through the air that find their way into your nose. Once in your nose, the compounds are absorbed by the mucus lining the nostrils, which then stimulates one or multiple of approximately 400 types of individual scent receptors. These receptors then trigger scent neurons that then send a message to the olfactory cortex, connected to the frontal cortex, which then registers the stimulus as a conscious thought. Another pathway an aroma can take is through the mouth. An aromatic compound can travel into the back of the mouth and up the retronasal channel to the olfactory receptors. Therefore, when you have a sinus infection and the sinuses in your skull swell, it is difficult to smell and the sense of taste becomes skewed because smell and taste work hand in hand. Now, while the concept of how the sense of smell works physically is relatively simple, the way that aroma works chemically is slightly more complicated. And what is even more complicated is trying to fit all the smells and their chemical compounds into a 7-minute video when some scientists have spent their whole careers researching the sense of smell and estimated that there are over 1 trillion individual smells. So for the sake of time, we're going to categorize the smells into 10 categories. These categories are fragrant, woody, fruity, pungent, chemical, mint, sweet, nutty, decay, and citrus. Terpenes, aldehydes, esters, amines, ketones, alcohols, aromatics, thiols, and lactones are the main players when it comes to the game of smell. Terpenes are isometric hydrocarbons that are usually found in essential oils. Terpenes are responsible for a variety of aromas such as fragrant, citrus, and mint. Aldehydes, characterized by a carbonyl group attached to a hydrogen atom, give off the woody and nutty aromas, and they're responsible for the delicious smell of cocoa. Esters, represented by the formula RCOOR, usually formed by the reaction between an acid and an alcohol with the elimination of water, and are the main source of fruity aromas found in flowers, wines, and fruit. Amines are a class of basic organic compounds derived from ammonia by replacement of hydrogen with one or more monovalent hydrocarbon radicals. Amines are responsible for the foul smells associated with decay, such as rotting meat, feces, and the smell of fish. Ketones are organic compounds characterized by a carbonyl group attached to 2 carbon atoms that range in aromatic signatures from fresh bread, the smell of metal, to blood and jasmine rice. Alcohols are compounds that are analogous to ethanol and that are hydroxyl derivatives of hydrocarbons. Alcohols are responsible for the chemical aromas such as menthol. Aromatics are created by the delocalization of electrons in a ring system, such as benzene, containing usually multiple conjugate double bonds. Aromatics can be linked to the smell of cinnamon, thyme, and vanilla. Thiols are analogous to alcohol, but in which sulfur replaces the oxygen of the hydroxyl group. Thiols are what give garlic its smell and are linked to the smell of mouse urine. Finally, lactones are cyclic esters formed from hydroxy acids. Lactones give coconut and peach their distinct smells. So, what do all these compounds have in common that makes them hold the ability to be smelled? Well, if you think back to the beginning of this video, then the answer should be clear. These compounds are in the air. They are light enough to escape the bonds of gravity to a certain extent through the process of volatilization. Volatilization is what happens to a compound when it evaporates, thus turning a solid or liquid into a gas. Once in the air, these volatile compounds drift around aimlessly until they are sucked into the airway of a living being or another fate becomes of them. To sum things up, smell is a very complex process. Smell starts with a compound that has evaporated or volatilized and becomes part of the mix with the air we breathe. Once breathed in, depending on the compound, one or many receptors in the nasal cavity are triggered. After these receptors have been triggered, these receptors then send a signal to the brain through neurons, and that is when the conscious part of your brain recognizes that you are around whatever is making the aroma.